So, in our last video, we talked about astronomy planets. And today we are going to talk about astronomy stars and galaxies. So let's get started. Okay, so first of all, I think it's really important to distinguish between stars and galaxies, because when I was in elementary school, at least in my country, they taught us that our sun is actually a galaxy, and it has planets revolving around it, and that is not correct. The sun is a star, and the planets revolve around it. Okay, so that's the basic difference. Stars can be of different colors. They have different sizes, shapes, and temperatures. Let's start with the color of the stars. The color of a star depends on its surface temperature. Red stars are the coolest, with a surface temperature ranging from 2000 to 3500 Kelvin. Yellow stars, like our sun, are medium temperature stars with a surface temperature of approximately 6000 Kelvin. And blue stars are extremely hot with a surface temperature of over 10,000 Kelvin. Now, here is an interesting fact. A star's color also tells us about its size. Hotter, bluer stars are usually smaller than cooler, redder stars. For example, our sun is a yellow dwarf star, and it has a surface temperature of about 6000 Kelvin. On the other hand, Sirius is a blue star with a surface temperature of 25,000 Kelvin, and it's much smaller than our sun. In addition to their color, stars also have different shapes. Most stars are spherical in shape due to gravity pulling matter into a round shape. However, some stars can have irregular shapes due to their interaction with other stars or gas clouds. For example, Wolf-Rayet stars are extremely massive and hot stars that are in the late stages of stellar evolution. As a result, they often have very strange and unusual shapes. Stars also vary in their chemical composition. Our sun is mostly made up of hydrogen and helium, but other stars can have different amounts of these elements as well as other elements such as carbon, nitrogen, and oxygen. For example, red giants are stars that are in the later stages of stellar evolution, and they have a lot of heavier elements in their atmospheres. Now, when we talk about the temperature of the stars, there is something called the stellar classification. It is based on the surface temperature of the star, and it is divided into 7 categories. The hottest stars are in Class O, and the coolest stars are in Class M. Class O stars are the hottest and most massive stars with surface temperatures above 30,000 Kelvin. Class B stars are still very hot with surface temperatures ranging from 10,000 to 30,000 Kelvin. Class A stars are white stars with surface temperatures ranging from 7,500 to 10,000 Kelvin. Class F stars are slightly cooler than our sun, and they range from 6,000 to 7,500 Kelvin. Our sun is a Class G star with a surface temperature of about 6,000 Kelvin. Class K stars are orange stars with surface temperatures ranging from 3,700 to 5,200 Kelvin. These stars are cooler than our sun. And finally, Class M stars are the coolest stars with surface temperatures below 3,700 Kelvin. These stars are known as red dwarfs. There are also different sizes of stars. Our Sun is considered to be an average-sized star, but there are many stars out there that are much larger and smaller than our Sun. Stars can be classified according to their size as well. The smallest stars are known as red dwarfs, and they are about 1/10 the size of our Sun. Our Sun is a yellow dwarf star and it is considered to be of average size. Giant stars are much larger than our Sun, and they are typically in the later stages of stellar evolution. Supergiant stars are the largest stars known, and they can be up to 30,000 times the size of our Sun. Stars also emit light and heat through nuclear fusion. Nuclear fusion is the process by which lighter elements such as hydrogen are converted into heavier elements such as helium, releasing a tremendous amount of energy in the process. This energy is what powers the light and heat from stars. Now, let's move on to galaxies. So, a galaxy is a massive collection of stars, gas, dust, and dark matter bound together by gravity. Our solar system is located in the Milky Way galaxy, which is a spiral galaxy containing hundreds of billions of stars. Galaxies come in different shapes and sizes. Some galaxies are spiral-shaped like the Milky Way, while others are elliptical or irregular in shape. Spiral galaxies are characterized by their flat disc-like shape, and they have spiral arms that extend from the center of the galaxy. Elliptical galaxies have a more rounded shape and they lack the spiral arms seen in spiral galaxies. Irregular galaxies do not have a defined shape, and they often have a large amount of gas and dust. One of the key differences between stars and galaxies is that stars are individual celestial objects, while galaxies are massive collections of stars. Stars have a definite lifespan, and they eventually die, while galaxies continue to evolve over time through the interactions between their stars and other matter. The life cycle of a star starts with the formation of a giant cloud of gas and dust. Over time, gravity causes this material to collapse, and as it collapses, the temperature and pressure at the core increase. When the core reaches a critical temperature, nuclear fusion begins and the star is born. Stars spend the majority of their lives in a state of hydrostatic equilibrium, where the outward pressure generated by nuclear fusion balances the inward pull of gravity. However, as stars age, the amount of hydrogen fuel available to them decreases and the core begins to contract. This contraction causes the surface of the star to expand and cool, causing it to become larger and dimmer. Eventually, the core becomes so dense and hot that nuclear fusion of heavier elements such as helium and carbon begins. This process makes the star even larger and brighter, turning it into a red giant. As the star continues to age, it eventually exhausts its supply of nuclear fuel and collapses under the force of its own gravity. The collapse can be so dramatic that the outer layers of the star are thrown into space, creating a spectacular event known as a supernova. The core of the star is left behind and, depending on its mass, can either form a neutron star or a black hole. In contrast, the life cycle of a galaxy is much longer and more complex. Galaxies form from the collapse of giant clouds of gas and dust. and they evolve over billions of years through the interactions between their stars and other matter. Galaxies can also interact with each other through gravitational forces, sometimes leading to the formation of new galaxies. The study of stars and galaxies is an important part of astronomy, and it helps us to understand the origins and evolution of our universe. By studying stars, astronomers can learn about the chemical composition, size and age of stars and how they form and evolve. The study of galaxies helps us to understand the large-scale structure of the universe and how galaxies form and evolve over time. And that's everything I wanted to share with you in this video. If you enjoyed the content, please don't forget to subscribe. Thanks for watching, and I will see you in the next video. Bye.